This video is on the objective graph a rose curve from a polar equation. Right. So this is going to be a special kind of polar equation. It takes on a certain form, and when an equation takes on this form, you should recognize it as the equation of one of these rose curves. And I'll tell you right now, the graphs don't look like roses. They look like daisies to me, with petals and stuff. You'll see, but they're called rose curves. I didn't get to name them. Alright, so here's the first question I'm looking at. Graph a rose curve from the polar equation. And again, if you want to see more about this, click on More Instruction. Alright, look at their videos, their notes, their examples, and hopefully those help you. In fact, I'm going to take you over some of the notes so I don't have to write too much down. So here, the next type of polar equation produces a petal-like shape called a rose curve. But you can see right here from this graph, looks more like a daisy. Anyway, although the graphs look complex, a simple polar equation generates the pattern. So the equation of a general rose curve looks like the following. Either r equals, some number, a, times the cosine of a whole number times theta, cosine of 2 theta, 3 theta, 4 theta, etc. Or, r equals a times sine of n theta, where, it could be the sine of 2 theta, 3 theta, 4 theta, etc. So if you see an equation like this, you're going to get one of these rose curves. If n is even, right, so if you have the cosine of 2 theta or the sine of 4 theta, the curve will have 2 times n, right, double that number of petals, right? And the petals are just these loops that come back on themselves, right? The petals of the flower, the petals of the quote-unquote rose. So if you have cosine 2 theta, 4 theta, 6 theta, 8 theta, or sine of 2 theta, 4 theta, 6 theta, 8 theta, the number of petals will be double that number, right? So the sine of 4 theta, that graph would have 8 petals. Right? The sine of 6 theta, that graph would have 12 petals. Right? And if n is odd, the curve has that many petals, n petals. So if you have the something times the cosine of 3 theta, there's just going to be 3 petals. Something times the cosine of 5 theta, there's going to be 5 petals. Right? So here's an example of, when n is even, double the number of petals. When n is odd, just that number of petals. Right. And then, again, this is how every single one of these rose curves will look, the equations. All right, so back to my problem. See how this is one of those rose curves? All right, so we have this equation in polar. R equals, -1 times the sine of 5 theta. All right, so you see here the value of, this is in that form r equals a times the sine of n theta, right? So if you or cosine, but if you recognize this is going to be a rose curve with, now since n is odd, right, n equals 5, an odd number, it's going to have 5. This is going to be a rose curve with 5 petals. All right. All right. And another thing I'll say about this that really wasn't mentioned here. If you recall from a while back, remember the value of the sine of an angle, the sine of something, the cosine of something? That never gets higher than 1 or lower than -1. Remember, the range was between -1 and 1. So this value of r, the highest it's going to get is -1 times -1, +1. And the lowest it'll get will be 1 times -1, -1. Basically, the length of the petals, let's say the length of the petals of this rose curve, which will be the distance from the origin to the end of the petal, it'll just be the absolute value of A, right? So that means, like, here's an example of a petal. Here's the origin, the pole, the origin. What I mean by that is that the distance from the pole to the end of the petal will be the absolute value of A units ln for all of these petals. Okay. All right, so that's another thing to note about these rose curves. All right. So what I'm going to do on this page, before I get into my polar grid, I am going to graph the y versus x version of this. So the xy version, not the rectangular. I'm not converting it to rectangular coordinates. Yes, it'll be x and y, but I'm just looking at an old version of our trig functions. You know, instead of r, y, and instead of theta, x. Y equals negative sine of 5x. And remember what this graph looked like, the way we used to graph things. All right. So this would have a period of 2 pi over 5. Right, so I'll go from, and it has no phase shift, right? No phase shift. Period of 2 pi over 5. I'll break this into quarters, so every pi over 10 for these special values, pi over 10, 2 pi over 10, 3 pi over 10, and 4 pi over 10. And then, again, the highest it's going to get is 1, the lowest it's going to get is negative 1, and, sine of 0 is 0. And the graph looks like this. Negative 1 here, positive 1, 0 there, positive 1 here, and then there. Right? And again, you should be able to graph some sine waves, cosine waves this easily. Now, if I want to go all the way around my polar grid, I need to do this till I get to 2 pi. Alright, so this picture is going to repeat when I get to, that's 2 pi over 5. When I get to 4 pi over 5, this picture is going to repeat, right? And I break this up into this period up into quarters. So it's 4 pi over 10. This is 5 pi over 10. 6 pi over 10. 7 pi over 10, and then 8 pi over 10, and again the picture would repeat, and so on. And I would do this until I got to 2 pi, right? I would do this until I got to 2 pi, and again, I'm hoping that after a little bit we'll see enough of a pattern to fill in the rest of the graph when we get through this. All right, so now I'm going to go to my polar grid. I'm going to make my polar grid on this page. All right, so remember how the polar grid looks. You have the vertical axis that really means nothing. It just divides the space into quadrants. Right. Then the horizontal axis is the polar axis. And like I said, the largest any of these petals is going to be is 1 unit away from the origin. So I'm going to make this 1 unit on the polar axis, right? And then this 1 unit up, this 1 unit left, negative 1, and then 1 unit down. Okay, and I'll draw this circle in. As remember, we're traveling on circles here. Okay. And then what I'm going to do is divide my quadrants up based on these special numbers that showed up here, right? These key values. Now pi over 10, that's 18 degrees, right? So I'm going to go every 18 degrees. And there should be, 5 of these in the first quadrant. So I'm basically breaking up every quadrant into 5 pieces. So 18 degrees, let's say that's that there. There's pi over 10. do another one. 2 pi over 10, that's pi over 5. 3 pi over 10. 4 pi over 10, which is 2 pi over 5. Then 5 pi over 10, that's pi over 2 here, right? And again, I'm just going to break up every quadrant into these 5 pieces, right? So bear with me here. I'm just going to extend these lines. And then do the same over here. 1, 2, 3, 4. And then here, this would be 6 pi over 10, 7 pi over 10, 8 pi over 10, 9 pi over 10, and then 10 pi over 10 is pi. And then just extending these lines over here. All right. And yeah, and I could do this all the way around. I mean, this is kind of annoying, but like if you were trying to do this by hand and didn't have any grid paper like I don't, so I'll just fill this in, right? So that's not 10 pi over 10, this is 11 pi over 10 then, 12 pi over 10, 13 pi over 10, 14 pi over 10, 15 pi over 10, which is 3 pi over 2, 16 pi over 10, 17 pi over 10, 18 pi over 10, 19 pi over 10, and finally, 20 pi over 10, which is 2 pi, right? So this corresponds to 0 and 2 pi. Wonderful. Now, let's take a look at different parts of my xy graph where, again, x represents values of theta, y represents values of r. Right? And look at each piece of this from special point to special point. So from here to here. So first see r is 0, the y coordinate 0, and the theta, the x coordinate is 0 as well. So I'm starting at the origin. That's this point here is on the graph then. All right. So 0, 0, 0 for r, 0 for theta satisfies this equation. Now, from this point to this point on this graph up here, the values of theta are ranging from 0 to pi over 10. So that means I'm in between these two lines, right, from 0 to pi over 10. But the values of r, the values of y, r, right, are negative. So over here, values of r would be positive, meaning to do negative r values, you do it on the opposite side of the triangle. You're over here. So between 0 and pi over 10, but with negative r's. So now I'm over here, between these two lines. Okay. And the value of r is going from 0 to minus 1. So I'm going from the origin to the circle with a radius of 1 between this and this. So like this here. Be like going from the origin and ending here on this circle with a radius of 1. So again, just this piece of the curve. A nice curve, smooth curve. And that's like half a petal. Right. And then in a different color, I'll do the next part. Right. So from this special point to this special point. So from here to here, the value of theta is going from pi over 10 to pi over 5. So between here and here, between pi over 10 and pi over 5. But if I'm over here, that would be meaning I had positive r values. But I do have negative r values. So I'm not going to be between here and here. I'm going to be between here and here. And plot the rest of my graph. And I'm going from r equals negative 1, so I'm on that circle with a radius of 1, going back down to where r is 0, going back down to the origin. So between here and here, going here, and cycling back down to where I'm back at the origin. So there's one petal. And again, there will be 5 of these. Alright, now, between this point and this point. So between pi over 5 and 3 pi over 10. So I'm in here now, between pi over 5 and 3 pi over 10. And I'll stay in here if we have positive outputs, positive y values, positive r values, which I do. So now the graph's going to be in here, not on the opposite side. And between pi over 5 and 3 pi over 10, I'm going from r equals 0 to r equals 1. So from the origin out to where I'm on that circle with a radius of 1. So again, another like half a petal. All right. Then, between these 2 points, theta is going from 3 pi over 10 to 2 pi over 5, so I'm in between here. The graph and the graph will stay in here if I have positive r values, which I do. If I had negative r values, the graph would be down here between on the opposite side. And I'm going from r equals 1 to r equals 0, so I'm on that circle of radius 1 and cycling back down, graphing back down to the origin, but just between those two. Right? So there's another petal. Now I'm back at the origin. This part of the graph. From this point to this point, between 2 pi over 5 and pi over 2. So between here and here, but I have negative r values. So I'm not going to be graphing between here and here. I'm going to be graphing between here and here on the opposite side. And I'm going from r equals 0 to r equals negative 1. So from the origin and ending at this circle with a radius of 1, right, to r equals negative 1 down here. All right. And again, there's the other half of the petal. And hopefully you can figure out the pattern here. All right, I will draw the rest of this in. All right, between 3 pi over 2, between pi over 2 and 3 pi over 5. Again, I'd have negative values, so I'm drawing in here. We're going back to the origin. Then between 3 pi over 5 and 7 pi over 10, we got positive values again, so I'm in this region, going back out to that ending at that circle with a radius of 1. Between 7 pi over 10 and 4 pi over 5, and here I have positive values, so I'm just coming back down to the origin. Then between 4 pi over 5 and 9 pi over 10, I'd have negative r values, so I'm not going between here and here. I'm going to be going between here and here. Right. And going back out to this circle of the circle of the radius of 1, and then coming back to the origin when I'm between here and here, but I have negative r values, so I'm over here. And that's it. I can go from just 0 to pi, actually. I didn't need to go all the way to 2 pi, because what's going to happen now is the rest of it's going to just cycle through this again. This graph will just get, when I go from pi to 2 pi, I'll just run through this same picture over and over again, right? A second time. So here's the graph of this, r equals negative sine of 5 theta on the polar grid. Right? I think they're pretty neat. Right? It's pretty fantastical. Now, if you want to see a prettier picture, right, you can go to there's an online graphing calculator that I've shown in other videos called Desmos. You go to desmos.com, free online graphing calculator. And if you type things in x and y, it's going to give you polar graphs. Rectangular graphs. And if you type things with r's and thetas, it'll give you the polar graphs. So here we had r equals negative, the sine of 5, and to type in theta, you just go theta. Just type in the word theta, and look at this. All right, and I'll zoom this in here. All right, and remember, I told you that there's exactly the same picture I drew, just with more colors. And remember, I told you that the largest value of r was 1. Here's r equals 1, right? The circle, the radius of 1, right? See how none of the points on that rose curve go outside that circle with a radius of 1. The farthest any point away is from the origin is 1 unit. Okay, so let me get rid of that. But that is exactly the graph. Right? All right, so back on the problem, right, we had to pick our graph here. Now, not quite this one. No, this would be it, right? There's a circle with a radius of 1 in here. It never gets outside that. It's got the 5 petals. This is our graph. All right, be careful, right? That last one had 5 petals too. But you see how some of the points were getting 4 units away from the origin? That wouldn't happen with this particular graph, because again, it's not going to get any further than the absolute value of A, that lead coefficient. All right, so hopefully watching me do this, looking at the more instruction, playing around with that Desmos website. In fact, you could probably just go to the Desmos site, punch it in, and then go back to the problem and pick the one that's correct. You can see the graph in Desmos right away. I just wanted to at least go over how to graph it by hand at least once, Yeah. Hopefully watching me do this, playing around with Desmos, looking at more instruction when you need to, reading the answer explanations when they come up, right? They can be useful. Hopefully all this stuff helps you out when you're going about doing this on your own. And thank you very much for watching.